Hey everybody, this is a short introduction to projectile motion concepts. In this video, I'm going to discuss what a projectile is, the trajectory of a projectile, how projectiles behave. They actually are just a combination of a horizontal type motion and a vertical type motion that we've already discussed. And I'll save the example problem for projectiles for another video. So, a projectile is just an object launched such that the only force acting on it is gravity, which means it's in free fall. The definition of free fall is that gravity is the only force acting. A couple of assumptions that we make is that gravity is assumed to be constant, which is a good assumption near the surface of a planet. For example, on Earth, the acceleration due to gravity is 9.81 meters per second per second. As long as we don't launch our projectile very, very, very high above the surface of the Earth, this acceleration is constant. We also assume air resistance is negligible. If air resistance were not negligible, it would complicate the motion of our projectile. It would be very difficult to analyze. So that means examples of projectiles involve baseballs that are pitched, batted, or thrown, bullets that are fired out of guns, a bus that goes off of a bridge is a projectile once it leaves the bridge, moving airplane with its engines and wings disabled so that it can't interact with the air, it's just falling, a runner in mid-stride, since they momentarily lose contact with the ground. When they're in the air, they act like a projectile, and a space shuttle or a spacecraft after the engine is cut off. The trajectory of a projectile is always a parabola. As you can see, these water fountains shoot out water, and that water behaves as a projectile, and it always forms this parabolic arc. You can see it here. To analyze projectiles, we're going to break their motion into their horizontal motion and their vertical motion. So let's think about what an object would do if there were no gravitational force. Well, if we fire something horizontally out of a cannon, then it just goes in a straight line at a constant velocity, because there's nothing to change its motion. Vx, we would say, is constant, or the acceleration in the x direction is 0. This is called the inertial path, or the gravity-free path. We also want to think about the vertical motion. So if we think about an object dropped near the surface of the Earth, it experiences a constant gravitational force, a constant acceleration. We can see that with this red ball that's dropped. It falls, but as it falls, its velocity increases. So we would say AY is constant. And on Earth, AY is just going to be equal to negative G Earth, which is negative 9.81 meters per second squared. And a projectile is what we get when we combine these motions. The horizontal motion is actually totally independent of the vertical motion. So if we launch something sideways in the air, its horizontal motion moves at a constant velocity, but in the vertical direction, its height experiences a constant acceleration. And we combine those, we get this parabolic path right here. And this is the most important fundamental concept for projectiles. Constant velocity motion in the horizontal direction and constant acceleration motion in the vertical direction. So we're going to analyze the horizontal, or the x motion, and the vertical, or y motion, separately. Let's take a look at this GIF first, though. Even though our projectile curves down, we can break its motion down into horizontal and vertical parts. The arrows on this GIF show the horizontal part of the velocity and the vertical part of the velocity at different times. These are also called the components of the velocity. Notice the horizontal component stays constant. Our horizontal velocity, or x velocity, is always 100 meters per second because there's no acceleration in that direction. In the vertical direction, that vector arrow gets bigger and bigger in the downward direction over time. It's because there's that downward acceleration, and it's about 10 meters per second each second that it speeds up. So in the x direction, we have constant velocity motion, which means that our x velocity is just displacement over time. And in the y component, we have a constant acceleration. Anytime we have a constant acceleration, we can use our Suvat equations. That's how we'll analyze the vertical motion. Notice that there is one additional equation given here. This is not going to be given to you, and this is not given to you by the IB, but you can derive this equation by combining two of the other Suvat equations. So our strategy for solving projectile motion problems is to break all of our vectors into horizontal and vertical components, which really just means our initial and final velocities. We'll go over how to do that later. Then we want to identify the interval of interest in our projectile's trajectory. That usually means drawing a diagram and figuring out what's going on at the beginning and end. Then we're going to list our givens and unknowns in a t-chart. We're going to break our motion down into x and y, and our x variables are going to be displacement, velocity in the x direction, and time. And our y variables are going to be displacement in the y direction, initial velocity in the y direction, final velocity in the y direction, acceleration in the y direction, which is just negative g, and time. And then we're going to use our constant velocity equations to analyze x, and our Suvat equations to solve for unknown variables in the y direction. In the end, we'll recombine our vector components as necessary if we want to find our overall resultant velocity. If we want to figure out the overall speed of our projectile, for example, when it gets to a certain point. One other important thing to note is time is the same for both x and y. So if we solve for time using one component, we know time for the other component. So oftentimes we'll solve for time using one component and plug that into the other component to figure out some other unknown variables. And that's about it. That's our overview of how to deal with projectiles. There will be a practice problem in another video. Bye.